Hello and welcome to this video looking at exothermic and endothermic reactions. So today all we're going to do is simply define these two terms. This is very much an introduction to the C7 module for GCSE. We're going to define these two terms. We're going to look at how we can measure it in a lab, so an experiment, and then we're going to just briefly touch on some applications of these two reactions. So, let's define exothermic first. So, an exothermic reaction, as hopefully you already know, releases energy to the surroundings. Easy way to remember that, exothermic, heat exits, okay? It goes away. So if we were to draw that in a little box where we had our chemical system, we would show the energy escaping like that. It's exiting, it's an exothermic reaction. And what we now need to think about is how this would actually feel and how we would go about identifying this. So if energy is being released to the surroundings, that would feel hot, okay? That is a reaction type that feels hot. Something like, for example, just combustion. Okay, if we think about our Bunsen burner burning methane, then that is combustion of methane. That's giving out energy, and the flame feels hot, where we're combining oxygen with our methane gas. So that would feel hot, and as a result, we're looking at a temp increase in this scenario. Okay, the temperature is going to go up in accordance with us losing this energy. Now we need to look at the endothermic setup. It's important to remember that every reaction is either endothermic or exothermic. There's no third option. And an endothermic takes in energy from surroundings. So if I was to draw the same chemical system, I'd show the energy coming in as energy coming into the chemical system. And if I touch that, that's going to feel cold. Think about the ice packs that you break. That's actually an endothermic reaction. And that's going to feel cold on my skin. So that will feel cold because it's taking that energy away from my hands or the thermometer. So I'm going to see a temperature decrease. So that's my two types of reaction, exothermic and endothermic. I've mentioned a few uses there, applications. This, anything you want to cool down. A sports injury in an ice pack is the classic example that I'll wheel out in an exam. This one, exothermic. More reactions are exothermic than endothermic because it happens much more spontaneously because we're not having to take energy in. The reaction just happens and releases energy. So this is actually much more common. We're looking at things like self-heating cans, combustion, anything to keep warm, anything to heat up food. That's all exothermic. So the final thing we need to look at is how we are going to measure these different reactions and how we're going to identify a reaction as either endo or exothermic. So typically in a kind of GCSE setting in the lab, we're going to be looking at setting up a calorimeter with a polystyrene cup. The reason we use a polystyrene cup is that it's very insulating, so we can measure the full temperature change. We are looking in these experiments for delta T, the change in temperature. Okay, And by using a polystyrene cup, we're hoping to see the full change in temperature. If we use something else, we might have losses to the surroundings, depending on if the lab is really cold or really hot. We could see quite different results. We then put that in a glass beaker, create a bit of a vacuum and stop people stabbing the polystyrene cup, and all the solution coming out. Now, we'd typically be looking at a liquid-liquid phase reaction, something like an acid and an alkali neutralization, or maybe a solid and a liquid, so metal and acid reacting together. We're going to put in a thermometer, obviously, because we want to measure the temperature change, and as we've said, temperature increase, exothermic, temperature decrease, endothermic, and we've got to look at that change in temperature. So you might have to analyse a start temperature and an end temperature and say if the reaction's exothermic or endothermic. And this is the setup we'd have. We'd allow the reaction to proceed. We would make sure we measured that initial temperature. So what was the temperature before we added the other reactant? Add the other reactant and then see how high the temperature gets or not. And then we could classify the reaction as exo or endothermic. So that's the kind of setup we would use. And in the next video, we'll look at reaction profiles and we'll see the effects of why an exothermic reaction is more common because of that drop in energy. So thanks very much for watching. Please like, comment and subscribe, and we'll see you in the next one.